What comes after the moon? It's a question that has intrigued scientists, engineers, and dreamers since Neil Armstrong took that legendary step in 1969. As monumental as the Apollo missions were, they were only the beginning, a proof of concept, a demonstration that human beings could escape Earth, travel through space, and set foot on another celestial body. But the true frontier lies ahead. In the decades since, technology has advanced rapidly, and the ambitions of both governments and private companies have grown to match. The moon is no longer the final destination. It is the gateway to everything that lies beyond. Today, NASA's Artemis program is aiming to return humans to the moon, not just for a brief visit, but to establish a sustainable presence. This time, astronauts will land near the lunar South Pole, a region believed to contain water ice, a vital resource for both life support and fuel production. The plan is to learn how to live and work on another world, to build habitats, test equipment, and prepare for even longer missions deeper into space. NASA, in collaboration with international partners and private companies, is also constructing the Lunar Gateway, a small space station that will orbit the moon and serve as a staging point for missions to Mars and beyond. And Mars is, without question, the next great goal. The red planet has captured our imagination for centuries. Its surface is littered with ancient riverbeds and flood channels, evidence that it once had liquid water, perhaps even oceans. Today, robotic explorers like NASA's Perseverance rover are roaming the Martian landscape, collecting samples and analyzing the soil for signs of past microbial life. In 2021, Perseverance deployed a small helicopter named Ingenuity, the first powered flight on another planet. These missions are more than scientific curiosity. They are laying the groundwork for human exploration. Elon Musk's SpaceX is leading the charge with its ambitious Starship program. Starship is designed to carry up to 100 people and is intended to be fully reusable. Musk's vision is to create a self-sustaining colony on Mars within the coming decades. While many experts consider this timeline overly optimistic, few doubt the trajectory. SpaceX is rapidly testing and developing the hardware needed for interplanetary travel, pushing boundaries that seemed impossible just 10 years ago. But human exploration isn't limited to Mars. Scientists are also eyeing the icy moons of Jupiter and Saturn, especially Europa and Enceladus. These worlds are covered in thick layers of ice, but underneath lie vast oceans of liquid water, kept warm by gravitational heating from their host planets. In 2015, NASA's Cassini spacecraft detected plumes of water vapor erupting from Enceladus, suggesting that the subsurface ocean is venting into space, potentially carrying signs of microbial life. Europa, too, is believed to have similar activity, and NASA's upcoming Europa Clipper mission, launching in the late 2020s, will investigate this further. If life exists anywhere beyond Earth, these are two of the best places to look. Meanwhile, telescopes like the James Webb Space Telescope are opening entirely new windows into the universe. Webb is already observing exoplanets, planets that orbit other stars, and analyzing their atmospheres. By studying the light that passes through these alien skies, scientists can detect the presence of gases like oxygen, methane, and carbon dioxide, possible indicators of life. In the coming years, Webb may find compelling evidence of habitability or even biosignatures on distant worlds light years away from Earth. Back closer to home, space tourism is becoming a reality. Companies like Blue Origin, Virgin Galactic, and SpaceX are offering suborbital and orbital flights to civilians. While the current cost is astronomical, it's expected that as the technology matures, prices will drop and access to space will expand. This isn't just about luxury travel. It's about normalizing spaceflight, developing reusable systems, and creating an ecosystem that supports more ambitious missions. If people can travel into space regularly, even just to low Earth orbit, it changes the entire economic and psychological landscape of space exploration. China is also making bold moves. In recent years, they've landed rovers on the Moon and Mars and are rapidly expanding their Tiangong space station. Their lunar program aims to send astronauts to the Moon by the 2030s, with plans for a research base near the South Pole. Their long-term vision mirrors that of NASA and ESA, establishing a permanent presence beyond Earth. supported by infrastructure, robotics, and eventually human colonists. To support all these missions, scientists are developing new propulsion systems. Current rockets are powerful but inefficient for long-distance travel. Concepts like nuclear thermal propulsion and solar sails could dramatically reduce travel time to Mars and beyond. NASA has already awarded contracts to begin testing nuclear propulsion technologies that could cut a Mars trip from 9 months to just 3. This would significantly reduce the risk to human health posed by cosmic radiation and microgravity exposure. And with distance comes the need for autonomy. On Mars or Europa, astronauts can't rely on Earth for immediate instructions. Communication delays can last from several minutes to hours. Artificial intelligence and robotics will play a crucial role in exploration, assisting with maintenance, navigation, data collection, and even emergency response. NASA and ESA are already deploying autonomous systems that can learn, adapt, and make decisions in real time, a necessity for operating in such remote and harsh environments. We're also witnessing the emergence of space mining, a field that was once pure science fiction. Asteroids like Bennu and Ryugu contain metals and minerals that are rare on Earth. In the future, these celestial bodies may serve as resource depots, supplying materials for construction, fuel, and life support. NASA's OSIRIS-REx mission successfully collected samples from Bennu and returned them to Earth, proving that such operations are feasible. Private companies like Planetary Resources and Deep Space Industries are exploring ways to commercialize asteroid mining within the next few decades. Perhaps the most profound aspect of future exploration is the search for life. It's the question that haunts us. Are we alone? The discovery of microbial life, even fossilized on Mars or in Europa's oceans, would be a revolution in biology and philosophy. It would mean that life isn't a miracle exclusive to Earth, but a common outcome given the right conditions. And if life is common, then intelligence too might be scattered across the stars. The future of space exploration is no longer a distant dream. It is unfolding in real time. It is powered by international cooperation, private innovation, and a deep human longing to understand our place in the cosmos. From returning to the moon, to setting foot on Mars, to searching for life in the oceans of icy moons or the atmospheres of far-off planets, this is a century where we stop looking up at the stars and begin living among them. The universe is vast, mysterious, and waiting, and for the first time in history, we have the tools to answer its call.